University of Auckland. He defended his thesis a few months ago, and so he's now officially Dr. Grade Manicom. And I think we've known each other for most of that time. He was part of a small discussion group in Auckland along with Sinead, his wife, sitting over there. And it's always been just delightful to listen to Gray talk about and reflect upon his faith and his work. And it's unusual, really, to find somebody who can get through a PhD in 3 years and do this kind of reflection, because it's not hard to do, it's not easy to do. At the moment, he's working for the COVID modelling Aotearoa as a research fellow, and we look forward to hearing what he has to say today. Thank you.
Thank you very much. So Jeff, I think, set the bar incredibly high, but he also got all the difficult questions, so that gives me some confidence. Good morning, everyone.
Good morning.
As Nicola was saying, I just recently did my PhD in mathematics. I'm now working as a research fellow in the Department of Physics at the University of Wellington, but I really do see myself more as a mathematician, not as a physics person. The title of my talk changed from what it was to not knowing better. And I showed my little graduation app. This talk will be quite anecdotal and reflective. Part of my journey going through my PhD and some reflections I have about doing a PhD in mathematics and what that, maybe some of those reflections, how they can help us in our Christian faith, or maybe as we think about our beliefs and things like this. In particular, I don't know if you've ever seen this curve, the Dunning-Kruger effect, also known as the feeling of understanding curve. And it basically goes like this. Let's see if the laser's... The laser's not pointing, so I'll just walk over here. So the x-axis here is your knowledge, or how much you understand in a field. And the y-axis here is your confidence, or how you feel, how much you feel you understand. And so basically, when you start off, you know nothing, and then you learn stuff, and it feels like you know all sorts of things. So you increase your knowledge, and your feeling of understanding goes up. But at some point, at the peak of Mount Stupid, you reach this kind of critical threshold of knowledge. And then as you learn more and more beyond that, your feeling of understanding, your confidence actually goes down. And you feel like you understand less and less until you reach this valley of despair. And then as you learn more and more beyond that, you actually start to gain in confidence, but the confidence you're now gaining matches your understanding until you become an expert over there. And in my PhD, I certainly experienced this, I think. I started off good grades in undergrad, thought, well, I really know what I'm doing, and started reading research papers, and then you think, oh, well, I kind of know what they're talking about in this paper, and then you start trying to actually do the work, and suddenly everything goes downhill, and you feel like you don't understand anything. And you kind of reach this part here. And I think part of the process of a PhD, and in fact, this research is very often done in the context of postgraduate degrees, is getting through this slump, doing the work, becoming an expert in some very small sub-discipline. And that's what you do in a PhD. And in mathematics, perhaps more than other sciences, you become an expert in a very, very, very small field. But I am confident now that if anyone wants to talk to me about heterotonic networks and their use in modeling cognitive dynamics, which is what my thesis was on, I'm just about as expert as anyone else is in the world. And that's a comfort, even though it's a very, very small domain of knowledge. So when I was thinking about this and reflecting on what I wanted to talk about today, it struck me that I've gone through the same journey with different aspects of what I believe in my Christian faith, in my Christian journey. And I think many of us can relate to that. And I want to start right away by saying, I don't think that means your whole Christian faith is on this point, like in the same place on this curve. But I think different parts of what we think or believe may be in different places along this curve. Perhaps more for younger people, I'm not quite sure. But when you first become a Christian, or when you first start engaging and reading the Bible, maybe reading a commentary, I think you gain a lot of knowledge and it feels like you understand what's going on. But as you engage with more and more theology, maybe you encounter certain scriptures that you really don't understand or seem to conflict with what you expected it to say, or perhaps there are certain social things or scientific paradigms or whatever that you struggle to align what you're reading about with. Often you kind of go through this deconstructive process where you've learned more, but it feels like you actually understand less, and your confidence is really low. And for a lot of lay people, I think you kind of get stuck down here. It's a bit demotivating, and then you also don't have the time to push beyond that and become an expert in one area or something like that. And I think that's quite a challenge for a lot of Christians. It has been for myself. And so hopefully through this talk I'll be reflecting on some of what I've maybe learned during my mathematics PhD and how that could maybe be helpful for how we talk about this from a Christian perspective. So the question, or the primary question I'm asking, is can the mysteries we find in mathematics inform us about how we think and feel about the mysteries of our Christian faith? So I'm going to split this talk into 4 different parts. I've already spoken a bit about the feeling of understanding. That's just some kind of context. I'm then going to spend a little bit of time talking about what I mean by mystery. Obviously, mystery is a big word and can mean many different things. I'll then talk about mystery at the foundations of our understanding. Again, this will be starting kind of from a mathematical perspective, but hopefully can help us think about our Christian journeys in a helpful way. And then how mystery is necessary for progress. And obviously, if I do my talk well and I increase your knowledge, maybe your feeling of understanding will go up. And if I do my talk really, really well, you'll all be leaving here feeling a little bit bewildered with little feeling of understanding at all. So let's begin with the word mystery. Because you might be thinking, well, can you really compare mysteries in mathematics to mysteries of faith in the first place? And I think you can, but it's helpful to be a bit more precise about this. I found a paper that I really recommend reading. It's quite short and really good, called The Logic of Mystery by Stephen Boyer. And he splits mystery into different categories, but he's got these 2 primary categories. And the first of these is what he calls investigative mystery. And this is the sort of mystery you find in a Sherlock Holmes novel, where there's some unsolved problem, and as you go around you get new pieces of knowledge, new pieces of information, and eventually all that knowledge comes together and it solves the mystery. And so in this type of mystery, knowledge is the thing that abolishes the mystery. As knowledge increases, the mystery decreases. The second type of mystery is what he calls revelational mystery. And this is the mystery that I'll closely link to what Paul in the Bible uses the word mysterios. And he calls this revelational mystery. And this is quite different because in this type of mystery, knowledge doesn't get rid of mystery. Knowledge is actually the foundation of the mystery. Stephen Boyer writes this: according to the biblical sense of mystery, the heavenly secrets may have leaked out, but they never quite make themselves at home on earth. There's always enough of the heavenliness about them to leave even those who know them overwhelmed. And this is the fundamental difference between a mere secret and a full-fledged revelational mystery. Where secret is hidden from outsiders, a mystery is hidden, period. It remains incomprehensible even to those who know it. And I think this is a really useful separation between the 2 different types of mysteries that I'm going to be talking about. This revelational mystery increases as we know more. Knowledge is the foundation of it. And I think I just want to point out here that this revelational mystery is not just restricted to theological things. It's not restricted to God. I think a lot of Jeff's talk that we just heard is of a revelational mystery type. We learn more and more. He shares this information with us. But the mystery of the cosmos seems to only increase the more he told us about it, right? Last night I went to a Hilary Hahn concert in Auckland, and listening to the music, I'm not a violinist, but I can imagine that the more I knew about violin, the more in awe I would be of the music being made by this virtuoso. And so I think we encounter these kinds of revelational mysteries all over the place. And so I'm going to be talking about these 2 types of mysteries, Again, kind of from a mathematical perspective, but seeing if we can bring some insight into our faith journeys. So I'm now going to look at mystery at the foundation of our understanding. To begin with, here are a couple of quotes. St. Augustine said, "If you understand, it is not God." Richard Feynman said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." And John von Neumann said, "In mathematics, you don't understand things, you just get used to them." Or at least he supposedly said that. And I think they're highlighting that you have revelational mystery here, right? These are three people who are experts in what they were talking about, and yet they said as you increase your understanding, the mystery is also increasing. There's something that seems mysterious and beyond. Just to track a bit of a historical narrative, in the 19th century, mathematicians went through a process of finding out all sorts of new mathematics that was good mathematics from a mathematical perspective. It was very sound and robust and very interesting, and yet it wasn't based in the physical, real world in any meaningful way. And for a lot of mathematicians, this was quite distressing. At the time, mathematicians didn't see themselves as mathematicians. They saw themselves as physicists, they saw themselves as scientists. These were all kind of one thing. And yet they were now doing mathematics that didn't relate to the science, that didn't relate to the physics. One of these mathematicians was Lewis Carroll, who obviously wrote Alice in Wonderland and had this wonderful quote, "There's no use in trying, one can't believe impossible things," Alice says to the Red Queen. "I dare say I haven't had much practice," said the Queen. "When I was your age, I always did it for half an hour a day. Why, sometimes I believed as many as 6 impossible things before breakfast." And this wonderful little story, I think, is Lewis Carroll trying to deal with the fact that as mathematics was increasing its understanding, there was something mysterious happening. There was a separation happening between the mathematics he was doing and the physical world around him. Well, that's how it seemed. And of course, this is revelational mystery of the kind of mind-blowing type. And it raises what I think is one of the really big questions of just everything. For me, why mathematics works is one of the great mysteries of the universe. And I think it's largely because when I've done mathematics, especially as I've done more and more advanced mathematics, I definitely experience it and feel like I am making it up as I go along. I'm reading papers that people have written, people that I'm having coffee with down the hall, and they've come up with new techniques. I've solved problems myself and I write the answer down. And in some sense, it all feels very human and man-made. And yet, when Jeff was talking about how art links the seen to the unseen, but clearly he was also talking a lot about how mathematics performs the same role. There's this strange thing that happens where, as we've looked at the universe, it's informed how we do mathematics, but as we do mathematics, we're then also able to project from within outwards and find that the mathematics is telling us a lot about the universe that we wouldn't be able to see otherwise. All those unseen things, the DNA, the telescopes, these things are almost all predicted mathematically first, and then we build the telescopes, we build the mathematical models to help us understand them. And this is a very, to me, mysterious process. I can't figure out why something that I'm coming up with would be able to do such incredible, powerful things. And this is the fundamental revelational mystery, I think, at the heart of mathematics. As we increase our knowledge of mathematics, this doesn't seem to go away. It just seems to become a bigger problem. Or a bigger mystery, I shouldn't say problem. So this was all happening in the 1850s, and towards the end of the 1800s and at the beginning of the 1900s, there was a great push amongst mathematicians to try and make mathematics kind of consistent in and of itself. They wanted to prove with mathematics that mathematics was good and sound and that you could do all this new mathematics, that it didn't have to be related to the physical world to be true or meaningful or anything like that. They really wanted to give mathematics mathematical foundations. And that was going quite well, I would think, until it all fell apart, were Gödel's incompleteness theorems. Now, I do want to put a disclaimer here. Some of you may have heard of these theorems, some of you may have read about them. Often I think people take them too far. I don't want to do that or give you, give you reason to think that these are the foundation of everything. But in the 20th century attempt to formalize mathematics, Gödel, a young PhD student, came along, and he came up with these two incompleteness theorems. So I'm going to have a couple of slides just to talk about the words that he uses, and then I'll actually have the incompleteness theorems, and then we can reflect a little bit about what this all means. So some of the jargon that he uses, the word axiomatic system. So here, an axiomatic system is a set of axioms with rules, which can be used to logically derive new theorems. So the starting point here is an axiom. That is basically an assumption that seems self-evident. It's an assumption that you can't prove, but it's a foundational starting point because you have to start somewhere. And these are typically, you want them to be as few as possible, and you want them to be as self-evident as possible. You definitely don't want something that could maybe be taken another way. And then you add certain rules to this, and then you can build new theorems from that. A complete system is a system in which every statement made in the language of that system can be proved to be either true or false. So if, for example, mathematics was complete, then every statement we made, every equation we wrote down using kind of normal mathematical language would be able to be proved true or false. You could prove that the left-hand side is equal to the right-hand side, or that the left-hand side is not equal to the right-hand side. A consistent system is a system which lacks contradiction, which is that you'll never have the left-hand side both equaling the right-hand side and the left-hand side not equaling the right-hand side. And so this push to kind of formalize mathematics was really a push to try and prove that mathematics was these two things. People were trying to prove that it was consistent, that you couldn't have one statement being proved both true and false, and they were trying to prove that it was complete, that every statement you made in the language of mathematics would be able to be proved either true or false. So Gödel then came along and he showed that neither of these is possible. Firstly, he showed that in any consistent system in which elementary arithmetic can be done, it is not complete. So whenever you have things and you can't have one statement being proved both true and false, then you'll always be able to get statements in that system which you can't prove either true or false. And secondly, he showed that any system cannot prove its own consistency. So this is kind of probably the most technical part of this talk, but what I'm trying to demonstrate here is that this kind of mystery at the foundations of mathematics, why mathematics works, is still a mystery. Even at the most foundational level, even from just within mathematics, we have no real way of saying that it will always work in the way that we expect it to. With that being said, there are very, very few statements in mathematics that we haven't been able to prove true or false. And the ones, there are examples where these, real life examples where these rules have been broken, and where we found statements in the language of mathematics that can be proved both true and false, and stuff like this. But they're usually very specifically designed for this purpose. In mathematics, for common use and everyday use, we haven't really encountered these as major issues, but they are there. So what does this mean? For me, it firstly means that there is mystery at the foundational level. Even in the most precise and, let's say, if there was one aspect or one domain of human knowledge and understanding where we would expect we could maybe get rid of mystery entirely, it would be mathematics. And yet even in mathematics, we have mystery at the foundations. We don't know why it keeps working. So standard mathematics is incomplete. There are things we cannot prove. And I think we can take some meaning about this to our Christian faith as well. especially for things like systematic theology. And I'm not just talking about systematic theology at like a high level. In our day-to-day lives, we approach our Christianity, I think, with some axioms. We have the things that we believe true. And yet we will be able to make, I think, statements in our theological language using those assumptions that we won't be able to prove are either true or false. They won't necessarily fit in easily. And sometimes I think that can be quite discouraging, but I find it encouraging that within mathematics we have the same kind of problems. This is just a limitation that we have to live with. Despite not being able to prove mathematics consistency, it is remarkably consistent. And that's what I was saying. Gödel's incompleteness theorems came out, I think, in the 1920s. And yet we've encountered no real-life examples where this has been an actual thing. Like, there are mathematical examples, but they are designed that way. They are searched for. And so I think for our theology, despite not being able to make certain faith claims, there are consistencies. So although we are dealing with something quite mysterious when we talk about God, like St. Augustine said, if you understand it, it's not God, there are still consistencies that we can rely on. And finally, there is revelational mystery in mathematics. And for me, this is probably the key point in this slide, is that religious faith is not alone in being very mysterious. Religious faith is not alone that as you increase your knowledge, your feeling of understanding might go down. This is actually something that we experience in all aspects of our knowledge and human understanding. It's maybe just more prevalent in religious journeys. And so, if there's one key takeaway point from there being mystery at the foundation of our understanding, it is that faith is not alone, that we don't need to think faith is isolated in being mysterious or maybe leaving us wanting to be able to solve problems that seem unsolvable. I'm now going to talk about how mystery, I think, is necessary for progress. So I found this gift when I was doing my PhD, and I quite like it. So the circle over here is all human knowledge. This is what you learn in primary school. This is what you then learn in high school. You then get a degree with a speciality. Then you get your master's degree. Then you start to read research papers, which takes you to the edge of our human understanding. And then you spend 3 years slaving away at a computer, and you make, hopefully, because you're meant to do a novel contribution, some little bump to the way we see the world. And so now, when I'm talking about mystery in this context, I'm going to be talking about investigative mystery. This is mystery that, as you know more and more, the mystery is going to get less and less, where previously I was talking about revelational mystery. And when you're at the boundary, I found it quite exciting space, but also a very difficult space, because you don't know what to do, and so because no one's done it before, and so it can be both very demotivating and very motivating at the same time. It's demotivating when you try 10 different things and nothing's working, but it's motivating knowing that this is something that no one else has been able to do, and so you're trying to do something for the first time. Things that you've read in textbooks in that bachelor's degree, in that master's degree, or whatever, that kind of all seemed like you would learn them and then you would do them. Now we'll have all sorts of problems or limitations that you weren't aware of before. And so you have questions of how this works. Why does it work the way that it does? But again, this is investigative mystery. This is the sort of thing, as you increase your knowledge, as you try different things, you're hoping that you get to abolish this mystery and solve the problem. Augustus de Morgan, who was around in the 1860s when mathematics was really going through this phase of transitioning from this physical science to its own thing, said, "The moving power of mathematical invention is not reasoning, but imagination." Einstein said something similar, where he said, "Imagination is more important than knowledge. For knowledge is limited to all we know and understand, while imagination embraces the entire world, and all there will ever be to know and understand. And I think the reason that imagination becomes so powerful in getting rid of solving these investigative mysteries is exactly because there is knowledge that is lacking. If you knew how to do it, there wouldn't be a mystery in the first place. You need to imagine a solution. You need creativity to push those boundaries. G.K. Chesterton, who I think I put a quote of his in every single talk I do, said, "There is a law written in the darkest of the books of life, and it is this. If you look at a thing 999 times, you are perfectly safe. If you look at it the thousandth time, you are in frightful danger of seeing it for the first time." And I really find this an encouraging quote. Again, not just for pushing through a PhD, but for faith. There are problems that you just have to persist at, that you need to go back to 999 times before it suddenly clicks, and you get to see it as if for the first time, and see it in a brand new light, and have it all make sense. And so I think mystery is necessary for progress. For mathematics, this can be demotivating, but also very exciting. But it's necessary for you to push those boundaries. What this could mean for our Christian faith and development, I think, is that a good question is far more satisfying than a cheap answer. If someone's struggling with a problem that's difficult to solve, that actually requires new knowledge to get rid of the frustration that they have, providing them with knowledge they already know is just going to frustrate them. But giving them a good question or a good place to look for more knowledge is going to be much more helpful. Also, it is frequently persistence that results in a new idea in the realm of mathematics. And I think for our Christian faith, we should be patient. This is obviously very difficult in an increasingly impatient world, and I certainly struggle with this a lot. I like to be able to solve all my problems very quickly and make sense of everything very quickly, but it just doesn't work that way. And finally, nobody becomes a PhD or a master in some field of mathematics only to do what is already known. You actually go through the journey of becoming an expert to do the things that are difficult, to solve the problems that haven't been solved. And I think for our Christian faith, if God's revelation was complete, then that would rob us of the joy of discovering new things and rob us of reveling in His revelation to us, to some extent. So, to summarize, we looked at the feeling of understanding, how through my mathematical journey, I certainly had this dip of feeling, increasing my knowledge, but having this slump and feeling like I didn't understand anything. And I recognize that I've been through that in my own faith journey with different things that I believe. We looked at what I mean by mystery, how some of my talk related to revelational mystery and some of it to investigative mystery. We looked at mystery, how it's foundational. It's at the foundation, I think, of all human endeavor. It's not something we can escape from, and faith is not alone in that. And we looked how, if we want to progress our understanding, whether in mathematics or, I think, in theology, we need to be able to embrace the mystery that's there for progress. Just one thing, Nicola was saying at the beginning that she added herself to the roster to get a bit more kind of demographic thing. And I'm also aware that for myself, although I'm like a white male, I'm also one of the few people here who's 30 or under. Just give me a few months and I won't be in that group anymore. But it does seem to me like this journey, this feeling of understanding hope, does relate more to younger people at the moment than older people. Younger people have maybe had a lot of their faith deconstructed, and so they find themselves in the pit of the valley of despair, as they called it, which is a tough place to be, and might need some encouragement and guidance in getting themselves out of that. So I thought I'd just end on that note. Thank you.